In this video, we're going to solve equations involving a single trigonometric function on a specified interval from 6.3. By specifying that interval, we're going to restrict the number of answers that we're going to be able to get. Otherwise, we would get infinitely many answers most often, unless there was no solution. So I'm just going to give you the example here that in the past, we have had the inverse trig function already written in the problem, and it only gave us one answer. Think of that as like how if I had the square root of 4 written in the problem, just x equals the square root of 4, and there's one answer to this, which is 2. But if I had the problem instead, x squared equals 4, and I introduced the square root into the problem, I'd have to put a plus or minus there to get both answers to the problem, because this would be equivalent to me saying x squared minus 4 equals 0 and factoring, setting each factor equal to 0 and getting x equals plus or minus 2, right? That we have to get when we have that square root property where we take the square root of both sides, we have to have a plus or minus, and we get multiple answers, right? Kind of the same thing is going to happen here, that when I introduce the inverse trig function to get rid of the trig function, when I isolate it, I'm going to possibly get multiple answers for the function. So for the equation, let's go ahead and let's work one out here, see if you can see what's going on here. So for this one, 4 sine of theta plus 3 equals 1. Theta is our variable that we want to solve for. It's trapped inside of the sine function. So we're going to try and isolate that sine function. 4 sine of theta equals -2. Let's divide both sides by 4, and we get that sine of theta equals -1/2. To get the angle outside of the sine function, we can use inverse sine, but let's just go ahead and let's just draw, because we know that we're on one revolution around the unit circle here. In which quadrants is sine negative? Well, it's negative in quadrant 3, it's negative in quadrant 4. So we're going to have a sine value of -1/2. These sides would be √3. I don't need them. I need to recognize what these angles are, measuring from 0 to the angle here. So this has a reference angle of pi over 6. So pi plus pi over 6 is 7 pi over 6. This one is almost 2 pi, but it's pi over 6 away. So it's 11 pi over 6. Reference angle of pi over 6 there as well. Right, let's look at this and say cotangent of theta is equal to √3. Cotangent is going to be positive in quadrants 1 and 3. Cotangent is going to be adjacent over opposite, adjacent over opposite, like that. Reference angle here is going to be pi over 6. And then pi plus pi over 6 is 7 pi over 6. 2 cosine squared theta equals 1. So that means cosine squared theta equals 1/2, which means cosine theta equals plus or minus the square root of 1/2, which equals plus or minus the square root of 1 over the square root of 2, which equals plus or minus 1 over √2, which equals plus or minus √2 over 2. So cosine, this is going to be all four quadrants. Going to have a cosine value of 1 over 2. Hopefully I did that right. So 1 over root 2, 1, -1, root 2, 1, -1, root 2, -1, root 2. And so we're going to have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 will all be correct answers to that one being restricted between 0 and 2 pi. All right, we're still between 0 and 2 pi here, but we've doubled our angle. So that makes things interesting. So that means that if theta is between 0 and 2 pi, 2 theta is going to be between 0 and 4 pi when we double everything. So now we want, where is cosine -1/2? So cosine is -1/2 in quadrants 2 and 3, -1 over 2. This is root 3, -√3, 2. So on my first revolution around, 2 theta is going to be, that's a reference angle of pi over 3. So that's 2 pi over 3. Then that's 4 pi over 3. Then I can go all the way around. Another 6 pi over 3 is going to give me 8 pi over 3. Another all the way around to get to here is going to be 10 pi over 3. Then I'm going to divide by 2 here to get my theta, which is between 0 and 2 pi. It's going to give me pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. 1, 2, 4, and 5. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. There's alternative methods to that as well, but I find this is usually the easiest one to go with here, is to list out all the angles in this interval here and then divide by that number. All right, now we need to use a calculator to solve that. The sine value is close to 1, so I'm going to have to be in, and this is going to be between 0 and 2 pi. So we're going to have to be in quadrants 1 or 2 where sine is positive. Go ahead and pull your calculator out. I didn't have it up on the screen. I didn't remember that I was going to need it here, but we're going to get this angle that's in quadrant 1. That will be the reference angle. So arc sine of, they want us to answer in radians. So 0.95. And they want us to round to 2 decimal places. So I get this as 1.25 radians. So 1.25, and then pi minus 1.25, or minus that answer that we got. Let's not round it until we need to, because we got 1.253235898. So let's get the most exact answer that we can here. And this angle to go all the way around here is going to be 1.89. And those are answers for number 5. Now let's look at 7 sine theta minus 3 equals 0. 7 sine of theta equals 3. Sine of theta equals 3 over 7. Again, this is not going to be something that we're going to just see on our unit circle, 3/7 is positive. So we're going to be in quadrants 1 and 2 here. We know that this is going to be 3/7, like so, but I'm interested in what this angle is here, just like the one above it. So arc sine of 3/7, and they tell us to answer in radians, and to the nearest hundredth, it's going to be 0.44. Take the whole thing and do pi minus that answer that you got from the calculator. And when you round that, you're going to get 2.70. Make sure you go to 2 decimal places when you do your rounding, because that tells you that there was a number, there was a 9 here, and this number was bigger than 5, and you rounded that 9 up to a 10. All right, that's it for this video, and we will come back next time, and we will talk more about 6.3. See you for the next video.